Identifying the chiral carbons. So we're looking for a carbon with 4 different things attached to it. Now here in 1A, anything with more than one hydrogen we immediately rule out. Anything with a double bond attached to it we immediately rule out. So that leaves us with this one. Are there 4 different things attached to it? We've got a methyl group, we've got a hydrogen. This end we've got an ethyl. This end we've got an ethyl with a double bond. So they're different, therefore that is a chiral carbon. This one here, we've got 2 carbons which we need to look at. So this one here has got, what's it got? It's got a hydrogen, it's got all that thing up that end, but 2 methyl groups. The 2 methyl groups are the same, therefore it's not chiral. What about this one? Well, it's got a methyl group and a hydrogen again, but this time the 2 hydrocarbon bits are different, therefore that is chiral. This one, what have we got? On carbon number 2 we have got a methyl group, a hydrogen, hydroxyl, and all of this stuff, so that is chiral. What about this one? We've got a hydrogen, a methyl group, we've got an ethyl group on this side, and we've got a hydroxyethyl group on this side, therefore that's chiral too. Now what have we got that's potentially chiral? We've got this, which only has 1 hydrogen, and we've got this which has only got 1 hydrogen. All the other ones have got either 2 hydrogens or a double bond. So what about this one? Well, we have a look around the ring here. Is the ring asymmetrical? Yes. The double bond is closer going around one way than the other. So that one is chiral. We have a look at this. Is the ring symmetrical or asymmetrical? No. In this case, there's an oxygen. Same distance away, either way you go around. So going around this way is exactly the same as going around that way. So that is not chiral, this one is. And this one, so what are the 4 groups attached to the chiral carbon in this one? Well, the chiral carbon, it's got to be this carbon, because this one and this one and this one have both got more than 1 hydrogen. So what are the different groups? Well, that way it's 1 carbon, so it's a CH3. That way it's 2 carbons, so it's C2H5. This way it's CH2OH. And then we've also, because the carbon here has only got 3 bonds to carbons on it, it's also got to have 1 hydrogen. Now, drawing this one out is very important. That's the only way you'll get your head around that one. So what have we got? We've got 1, 2, 3, 4 carbons in the chain. Then we've got a hydrogen and a CH3. Next carbon's got a hydrogen and a bromine, and then a CH3. So we see that is not chiral because you've got the 2 CH3s. This one is chiral because bromine, methyl, hydrogen, and then the propyl group there. And here's a nice neat version of it. And get ascorbic acid from your data book, of course. If ever you're given a question about an organic molecule you don't know, check your data book. And you'll find 2 chiral centres, hopefully. So what have we got? We have got Again, we look for carbons that have got 3 things attached. So that looks pretty good. Go around that way they're different. You've got a hydrogen and you've got that stuff which is different. So that's chiral. This one looks as if it might be chiral too. It's got a hydrogen, hydroxyl, it's got the ring up that way, it's got the CH2OH down that way, so that's chiral as well. All the other carbons have either got 2 hydrogens, double bond, double bond, double bond attached.